polytropic process or the general process, which is represented by PV raised to n is equal to constant, where n represents the index of polytropic process. Now it will be interesting to see that a polytropic process can be any process. For example, if you look at this graph, you can see when the value of n is equal to 0, that means pressure will be equal to constant. Again, when the value of n becomes infinity, then the volume will remain constant. That is, it becomes an isochoric process. And when the value of n is equal to 1, then PV is a constant and it becomes isothermal process. And when n becomes gamma, as we mentioned in the last video, it becomes the adiabatic process. So here, polytropic process is a general process, and we have already done, see, for constant pressure process, we know that the work done is equal to P into V2 minus V1. Again, for a constant volume process, we know that W is equal to 0. Then for a constant temperature process, we derive the equation W is equal to P1 V1 ln V2 by V1, or it is also equal to P1 V1 ln P1 by P2. Again, for a constant, it's not constant if you take a constant heat transfer process or an adiabatic process. For an adiabatic process, again we derive the work done as P1 V1 minus P2 V2 by gamma minus 1. Now, as we mentioned, the value of n is what changing in all these processes. So whatever we have derived during the adiabatic process, there instead of gamma you put the value as n or put n, then it becomes a polytropic process, and therefore the work done during a polytropic process, W is equal to P1 V1 minus P2 V2 by n minus 1. N minus 1. It can be also written as W is equal to P1 V1 by n minus 1 into 1 minus P2 by P1 raised to n minus 1 by n. This equation can also be used for finding the work done during a polytropic process. So the derivation, it's exactly same as the adiabatic process. Instead of gamma, you just substitute the index n, and that will give you the work done.